In React, there are tons of different hooks, and most tutorials will cover 5, maybe 10 of them, but there are so many beyond that that most tutorials completely skip. In this video, I'm going to be covering 7 of the most advanced and niche React hooks out there that you may not use every single day, but as soon as you run into the need for these hooks, they are the only way to solve these particular problems. Now, the first hook that I want to talk about is definitely the most common out of these hooks that you're going to be using the most, and it is the use hook. Now, I currently have a really simple application where I have a theme context wrapping my entire application essentially with a value of dark. And then if we look at our client, we're just doing some fetching of data, very standard data fetching. You can see when I refresh my page, it says loading, and then it shows me my data as well as what my theme is. So if we look down here, you can see our data plus our theme is the thing being returned. While we're loading, we get the loading state. And if there's some type of error, it throws us this error state. So if, for example, I just change this to be a reject instead of a resolve, and I just come in here and reject our promise, you'll notice this says error now instead of the data. So we're just seeing that that's a really simple piece of code. You can see we have state for tracking our loading, our data, and our error, and then we just have a simple use effect that sets all that up for us by calling this fetch data, which is some type of asynchronous code. This could be a network request or anything else. It doesn't really matter. It's just some type of asynchronous code. This is probably something you've seen all over the place in React, and it takes quite a bit of code to be able to write something like this. So instead, I'm going to show you an alternative using the use hook that simplifies a lot of this code when you're dealing with asynchronous stuff inside of React. So the first really nice thing that we can do is we can actually get rid of every single piece of code inside of here, except for our theme, because that's obviously unrelated. And instead, we can get our data by just calling the hook use. This is a simple hook called use. And then inside of it, we need to pass it some type of promise or async piece of code. So in our case, we can pass it that fetch data function just like that. And now we have our asynchronous code being passed to that use hook right here. We no longer have our loading and error state because that's actually handled outside of this particular component. So we can get rid of everything with use effect, use state, all of that code we completely get rid of. And now instead, all we need to do is wrap this inside of a suspense. Essentially, the use hook allows us to use suspense for all of our loading state related code. So here we can put a fallback that says, for example, loading, just like that. And now we have that loading state showing up for 1 second, but you'll notice what really happens is we get an infinite loading state. The reason for that is a little bit convoluted, but essentially what's happening is we call use and it's getting our fetch data and it's getting a promise being returned. So it waits 1 second, executing that promise, and it shows this suspense fallback state right here. Then after that full second is done, it says, okay, I have my data. So it re-renders our component from the top, gets our theme, gets fetch data again, which returns a brand new promise, and then it restarts the fetch again. So essentially every second it's kicking off a new fetch request, so it never finishes loading. So when you use this use hook, you need to make sure that the promise that you're passing to it doesn't actually change. It has to be the same promise. An easy way for us to get around that particular problem is just to create a variable called promise. We'll say it is a promise that returns a string, just like that. And then inside of here, I can just say if our promise is equal to null, then what I want to do is essentially set our promise to this new promise and then return our promise down here. This is essentially like a singleton pattern. I'm just making sure that I only ever have one promise and never recreates the same promise. So by doing this, if we just refresh our page, you see it says loading for a second, and then it shows us our data. So automatically we're able to take all of our loading data and error data and all that state stuff, and we're able to get rid of all of it and instead just wrap this component in a suspense that handles this loading state for us. Now that takes care of the loading state, but in order to handle the error state, we need to use something called an error boundary, which is kind of a weird React concept. We need to create a function or a class actually technically because it only works with class components. You can call it whatever you want, extend component, and really all this needs to do is it needs to implement the static function called getDerivedStateFromError. This is actually going to take in the error information and everything else related to it, but essentially this function will be called anytime you have an error and it'll pass along the error. In our case, we're not storing the error. All we're doing is we're just saying, hey, if it has an error, we're going to set that to true. So anytime there's an error, we set this to true. And when we render out our code, if there's an error, it'll render that out. Let's just make this an H1 for our particular use cases, so it matches the code we had before. So if we have an error, it renders the error. Otherwise, it renders the children as is. This is essentially a weird kind of thing that you need to do in React to catch an error. But if a use hook inside of it, the promise fails, what will happen is it'll call the closest error boundaries getDerivedStateFromError function. That's all that will happen. So if we wrap our code inside of this, we can actually see what happens. So we can say error boundary, just like that. There we go. And now what we can do is we can go into our client, and instead of resolving, we will reject this promise. And we can see we now get that error state showing up because essentially it's calling this function right here, sets has error to true. And if has error is true, it just returns an H1 instead of returning whatever the children are. Now, creating your own error boundary is kind of annoying, especially as you want to get more complicated behavior. So there's actually a library you can use called React Error Boundary, just like that. You can install this library right here instead if you want, and you can use the error boundary from there, which is a much more advanced version of what this error boundary looks like, but that's kind of beyond the scope of this particular video. So this is the main way you're going to be using the use hook. You just pass it whatever promise that you want to use, and make sure it's stable, it's not recreated every render. Then you wrap that component inside of a suspense and an error boundary, or you can have a global error boundary, for example. At the minimum, you want to have a suspense for that loading state, and then you can just use the data directly inside here. It's almost like being able to put a weight directly in line, but since this doesn't do a weight, this is essentially the workaround for that. Now you're probably looking at this and wondering why I have this whole use context thing inside of here, and that's because the use hook can also be used with context values and not just with promises. So I can replace use context with use, and my code is going to work exactly the same. We'll just make sure that this changes back to response, and we give it a quick save. You can see that it still gets my context value just fine. So you can replace use context with use, and everything is going to work exactly the same. The benefit of doing something like this is that the use hook is actually special in that it breaks all of the traditional hook-based rules inside of React. You know that the React rules say that hooks must be at the top of the file, they can't be conditional, they must be called in the same order, you can't put them inside loops. All of those rules do not apply to the use hook. I can come in here and I can wrap this inside of an if statement if I want. So I can say if, and I can put whatever statement I want inside of here. So we'll just say math.random is greater than 0.5. Well, then what I'm going to do is I'm going to run this code inside of here and set my theme variable to this. Otherwise, by default, let's say that my theme variable is set to light. So now if I give that a quick save, you can see it first says that it's going to be dark. Let's refresh again, and we'll see that it is now light. So you can see, depending on what my if statement is, I can run this use hook or not, and everything in React doesn't care. It's going to work just fine. And this works with a context. It also works if you pass it a promise. You can put this inside of a loop. You can literally put this hook anywhere that you want. So it's really technically not even a hook, even though they called it use with the naming. So it's kind of named like a hook, but it doesn't have any of those similar rules like React hooks do. So the whole idea of this hook is essentially to let you do asynchronous code anywhere you want without having to handle all the loading and error states yourself. It lets you fall back to like error boundaries and suspense, which are some standard React-based things that are really easy to work around. Now, I also am going to show you how this works in Next.js specifically, because there's a little bit of interesting stuff when you start dealing with server components. Now, here's essentially a simplified version of the code directly inside of Next.js. You can see that inside of our page, we're still wrapping everything inside of a suspense. This is a server component, which is the key thing that we're going to be talking about. And you can see here I have a client component, which is marked as a client component, and I'm passing along my promise. This is something that you can do inside of server components with React. It doesn't have to be just Next.js. Anything that supports React server components will allow you to do this. You can pass a promise from a server component down to a client component, and then you can use that inside your use hook, and everything is going to work perfectly fine because essentially it's passing along a stable promise object. It's not recreated on each render. So this allows you to essentially pass along the ability to do asynchronous code on the client. So you can see when I refresh, I get that loading state, and then after a second, it shows my data. And every time I refresh, it's going to work perfectly fine because it's passing down a brand new promise every single time. But each time my component re-renders, that promise stays the same since it's coming from the server. So if you're working with React server components in Next.js or some other framework, just know that you can pass promises down to client components and you can use them in this use hook if you want. Now we're going to stick with the React server components on Next.js because this next hook is actually really useful when you're dealing with server and client components. So on my client component here, let's say that I want to specify an ID for this H1, and instead of just hard coding it as a specific value, maybe I'm generating this dynamically inside of a component. So I need to use a random value for this thing. Well, you may think, okay, I'll just come in here with like a math.random. That's perfectly fine. And we can convert this to a string just like that. And now we have essentially a random dynamically generated ID. And we could even maybe try to generate this outside of the component so it's not randomly generated inside of it. So we can say like ID is going to equal, this random ID right here. And then we can pass that along just like this. And you'd think, okay, everything is going to work perfectly fine. Let's refresh our page and see if everything works. And you notice we actually get an error down here as tree is hydrated, blah, 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 blah. Essentially what's happening is that we get one random number on the server and we get a completely different random number on the client because it runs this code both on the server and the client. And if you have two different values, one from the server and one from the client, and they are different from each other, the React components are essentially going to throw you an error that says, hey, we weren't able to hydrate properly. Essentially, your server code was different than your client code, so we are unable to handle this in the proper way. This is something that you don't run into all the time because oftentimes you'll just come in here and you'll actually hard code a specific ID. But if you have a component, for example, let's just say that we have a component called field group, and this field group component is going to return to you multiple different things. So we'll return a div that has a label inside of it, and that's just going to be whatever the label is. And then it's going to return to us an input as well. Well, we want to link these up with two different IDs. So we're going to have an ID here, and we're going to have an ID here. And this one should say HTML4. That way it links these two elements together. But since we can use this field group in many different places, we either need to pass the ID in as a prop, or we need to dynamically generate an ID for every single time we call this with something like math.random, so it's entirely randomly generated and won't clash with other IDs on our page. This is something that in the past you were unable to do in React, but there's a brand new hook called the use ID hook that allows you to create dynamically generated IDs that will never clash with each other, but are also consistent. So when you render on the server and the client, you get the exact same ID returned both times. So here what I can do is I can just say const ID equals use ID, and that's going to give me a completely random ID. But the important thing is it's consistent. The next time I call this on the server or the client, it gives me the exact same values. So if I save and we refresh our page, you'll notice when it finishes loading everything, we get absolutely no errors at all. And that's again because this is a stable ID. It's the same on the server and the same on the client, but it's guaranteed to be unique, so it'll never clash with any of the other IDs that are on our page currently. This is perfect for when you have something like a field group here where you need to generate a random ID that you can use in multiple different places, such as right here. Pretty much the main place that I use this use ID hook is when I'm hooking up different accessibility features such as HTML4 and so on, but you can use it in many other places where you need a unique ID that's stable between the server and the client. And even if you're not using the server, this is still useful for things like a field group component that you purely use on the client with no server rendering with Next.js or anything like that. Now for this next hook, we're jumping back to the client because it has nothing to do with server rendering at all. And this is the hook use effect event, which is really useful when you're doing specific things inside of use effect. Take a look at this simple code here. We have a component, which is just a child component that takes in a username as well as a URL. And it doesn't really matter much what this component does other than the fact that inside of this component, I have a use effect. And every time my URL changes, I want to fetch new data. So we're calling some asynchronous code to fetch data. You can see the code doesn't do anything, but you can imagine like a network call or something like that. We're doing something to fetch some data. And then every time we fetch data, we want to log this out to some type of logging service we have. It doesn't matter what it is, but we're logging this data saying, hey, this user has fetched this particular data. So you can see we're passing in the URL and the username of the data they're getting, as well as the person fetching that data. But you'll notice in our use effect, we have a warning. Essentially, it's saying use effect is missing the dependency username because we are using that inside of our use effect. So you would think, okay, I'm just going to come in here, I'm going to paste my username down, but now we have another problem. And that is that this function for use effect, really all we want to do is rerun it when our URL changes. But now we're rerunning it not just when our URL changes, but also when our username changes as well. So essentially, we are now calling this fetch function way more than we may want to, because if this username changes a bunch and the URL stays the same, we're fetching the data a bunch of times, even though we're fetching the exact same data. This is a huge problem that people would run into with the React use effect hook before this new use effect event hook was introduced. And you could get around this by ignoring this error with like different ESLint warnings and stuff like that. But instead, what we're going to do is we're going to make this work perfectly fine without having to do any hacky stuff like that. So we can use a hook, which is called use effect event. And this use effect event just takes a function and it's going to return to us a function as well. So we can say that this function is going to be our logger function. And inside this, all we need to do is we need to call a particular function. So we can just say inside of here that I want to call send to logger, and I want to pass it in my URL and my username just like that. And then we can use our logger inside of here instead, just like that. Now, immediately by using the logger inside of here, you notice it completely gets rid of all of our errors. And that's because essentially the way that this works is when you use the use effect event hook, it'll always use the most up-to-date version of these values. So whatever the most up-to-date URL and up-to-date username is, it'll use those, and it will never cause a dependency refresh because this logger function essentially never changes. So it'll always make sure to use the most up-to-date versions of our state and props. But since this function for logger technically is exactly the same every single time, we don't need to include it in our dependency array. So this is a really great way for us to essentially circumvent that need to include username in the dependency array, because we actually put it directly inside this use effect event. So anytime you want to do something as a side effect of a use effect, but you don't want that use effect to rerun when certain variables change, make sure those variables are wrapped inside a use effect event inside of a different function that they're going to be calling. And we could take the code from this send to logger and we could just use it directly inside of here. You don't have to directly call that function. This would still work exactly the same as before. Now, the important thing to note, though, is since these always get the most up-to-date pieces of information, if we call logger, for example, inside of the .then of our fetch data, and our fetch data takes 20 seconds to execute, in the meantime, if our URL changes, it'll print out the new value here while we technically were fetching with the old value. That's why if you're using use effect event, any of the dependencies inside your use effect should be passed into this function instead of being relied upon. So instead, I'm going to pass my URL into this logger, and I'm going to get my URL here. And we're going to call this something different to make it really clear that this is our current URL being passed in, and I want to use that current URL here. So essentially, this username value is just using the most up-to-date version from our props, while this current URL is specifically using the value from the use effect itself. Technically, you don't have to do this. It'll still work the same either way if you do this or not. But by making sure you do this instead, it'll mean that if your URL changes between the time when you actually use it in your use effect and the time that you call this use effect event function, it's going to make sure it uses the correct value instead of using a more up-to-date or newer value. Now, the next hook that I want to talk about is a very simple one that is specifically used for custom hooks. So let's actually drastically clean up this data right here. We don't really need to even return anything. All we're going to do is use a custom hook, which is going to give us our online status. So we say is online is equal to use online, which is a custom hook I've created. We'll take a look at the actual implementation of this hook in a second, but it just returns me to the status if I'm online or not. So we can just return is online just like that. And we want to convert this to a string or something like that. So we can just say is online. If it's true, we can say online. Otherwise, we could say offline. There we go. So now you can see, since I am currently online, it says online. I'm connected to the internet. If I were to go over to my network tab, for example, so we can come to my network tab, I can actually emulate what it is like to not be connected. So by clicking on offline, you can see by going offline, it changes to offline, and here it's changed to online. So we can see that at least this hook is working like we expect it to. The problem comes when I start to inspect my dev tools to see what's going on. So let's go inspect this again. And inside the dev tools, we can go to this component section. I want to click on our app here, and I want to dive a little bit into the actual dev tools at the bottom. So let's minimize this down to make it a little bit easier to read. Here we go. And you can see in this bottom section here, we have this hook. You can see it says online. And if I expand it, we just get state true and in some effect. So this really doesn't tell me data about my hook. You can see the hook is called online purely because it's called use online. It just removes the use portion from it. And it tells me the hook's inside of it, but I don't know anything about this hook. Am I online? Am I offline? I have no idea. So if you find yourself writing these hooks that are used in many places in your application, you want to be able to debug what's going on in them inside the React Dev tools, what you can do inside your hook is you can use the use debug value hook. This use debug value hook just allows you to pass in a value that's going to be returned. So we can say if we are online, it'll say online. Otherwise, it'll say offline like this. So now if I inspect my page and I go over to that components tab again, you notice we are technically getting an error just because of the way the refreshing is working. If I do a full refresh my page though, and we scroll down, you can now see the text online is showing up next to my component. And if I were to go offline by going over to the network tab, the network tab specifically, and I change this to offline, and then I go back over to the components tab, you can see that this is changed to offline. So essentially it's taking whatever text you pass to use debug value, and it's putting that right next to where your hook is, so it's easy to see what's going on. Now let's make sure we actually change our network tab back to being online. There we go. Also, one other really small thing about this hook is sometimes, since this is only for debugging, you don't want to run really expensive computations inside here. Like let's say you had a list of hundreds of items and you needed to loop through those items and concatenate them and do some stuff with them before you displayed what the label was. What you could do instead is you could pass along what your value is as the first property. Then you could pass along a function as the second property, which takes in whatever your first value is. So it's going to take this is online, and then you can do whatever you want with this. So I could say if my value is this, then I do online. Otherwise, I do offline. And this function is only going to get called when you specifically open the dev tools and inspect this component. So this is a great way for you to offload essentially the parsing of that data if it's really computationally expensive, because you don't want all these debug value hooks slowing down your application for users in production or other places where you're not actually using this use debug value stuff. So this is a great way, like I said, to offload that performance. For the most part though, when I'm using these, I don't have really complicated expensive operations. So I just write my code something like this and it's going to work perfectly fine. Now, the reason I specifically created this hook is because I want to show you another hook, which is the use sync external store hook. This one has a really complicated name, but it's really great when you want to sync up state inside of React with something that is external to React. And this is a perfect example. You can see we're essentially creating state for our online status, and then we're hooking it up to a bunch of different event listeners inside of our code to be able to change that status. So you can see here we have an isOnline Boolean set to whatever our online status is from the browser. Then inside this use effect, I'm just adding an event listener listening to the online and offline events, which are events directly built into the browser that will toggle whenever you go online or offline. And I'm just updating this set is online status to that value. But again, I'm trying to sync up my React state with something that is external to React, specifically this browser-based code. And the use sync external store is the correct way to do that, and it makes your code a lot easier to work with and understand. So what we're going to do is we're going to change this completely. So we're going to say const is online is going to be equal to that use sync external store. And the very first thing that we pass into this is a function that allows us to subscribe to this. And it essentially is just a use effect. So we're going to call this subscribe, just like that. And this is a use effect that is only going to run one time on our page. Technically, I actually wrote this use effect incorrectly because it should have essentially an empty dependency array on it. But in our case, this is essentially what that subscribe function is going to be. So let's create a function called subscribe, just like that. And essentially I want to take all the code that's inside of here and I want to paste it down here. And the reason that I'm doing this is because this function subscribe is going to call itself with some code. And then anytime it needs to refresh itself because the component's re-rendered, or to clean up any event listeners because the component is unmounted, it's going to call this return value just like a use effect would. But essentially it's a use effect that only runs specifically when we are doing the very first render of our page. So I've just copied that down for now. We can get rid of this entire use effect here. We'll get rid of the use debug value as well for now. And we need to pass along a second parameter to this as well. The second parameter to this is going to be a function, and this function is essentially a snapshot function. All it does is anytime that React needs to get a new value for what this state should be, it's going to call this function. So this function should return whatever the new version of our state is, or whatever the current version is. In our case, we can just say here that we want to go navigator.online. That just returns to us whatever the currently online status is. And the reason that this works is because this state is handled outside of React. This online status is handled by the browser. It's synced up properly to this property inside the browser. All we're doing is we're telling React, okay, if you want to get the current version of this property, call this function, it'll return to you the current version, and it's going to set it to this variable right here. And inside of subscribe, we actually get a callback function being passed to it. This callback function is just a function that does nothing at all. You just call it and it returns void. So there's nothing you have to worry about inside of it. But essentially, anytime that your state updates inside this store that's external to React, instead of you having to manually sync everything yourself, you just tell React, hey, here's this function I want you to call. It is called callback. Go ahead, call this function. And essentially what React does when you tell it to call the callback is it calls this function right here and updates the new value. So anytime our online status changes with this online or offline event, what happens is React calls this function right here and then returns that value as our isOnline status right here. So now we should have everything working exactly the same as we did before, but you can see our code that we have written is quite a bit more concise. And when you have a more complicated store, something that's a lot more complicated than just a single Boolean, you can see that this version of writing your code makes it much simpler. So let's actually inspect our page. We'll toggle our offline status to make sure everything still works. We go offline, you can see it changes to offline. We go online, it changes to online. And that's because instead of storing your own state inside of React, React is just saying, okay, I'm going to say that this is our current value of the state, and you just tell me every time it changes. So I'm just telling React, hey, it changed, and React just gets the new value directly from here. There's no state being stored or anything like that. It just gets the new value every single time it changes. Now this function also takes a third parameter, and this third parameter is only applicable if you're working with server components. And essentially, this is what's called on the server. So we could say true, for example, and now when this component is rendered on the server, instead of trying to access these browser APIs, which it doesn't have access to, it just calls this function and returns true as the default value. Then it's going to render on the client, and it's going to call this code right here, which is the client version of it. And every time we call callback, it uses this client version here. This third parameter is purely only there for when you're rendering a server component. So when you're rendering on the server, if you don't have access to the browser, you can render out some specific data right here. Now in our application, we don't have any server rendering, so I can just completely get rid of this. And that's going to be all we need to do to make this use sync external store work. Now this component, or this hook I should say, is really most useful when you're syncing up things like browser-based APIs or you're working with a library that's not built for React. It's a library that manages and stores all of its own state, and you want to sync up the state from that library with your actual React code. This is the hook that you're going to use to do that. Rather than writing your own use effects and use states, this hook just makes working with all that so much easier. Now, the next two hooks that I want to talk about, I'm going to recommend that you use incredibly sparingly because they kind of break out of the entire React ecosystem way of doing things. And the first one is the use imperative handle hook. So what we're going to do is we're going to change our code quite a bit. We're just going to create a simple function. We're going to call it child. It doesn't really matter what's inside of here. Let's just say that we have a div, which is going to have an input. There we go. And let's say that we have another input. Doesn't really matter. So we just have two inputs. And if we just render that out, we can see those two different inputs on our page. If I zoom it out, make it a little bit wider, you can see we have input 1 and we have input 2. Relatively straightforward. And we know that if we want to get a ref of an element, well, we can just get the ref directly. We can say ref like this is equal to ref, and the ref gets passed down as a prop in newer versions of React. So we can come in here and we can make sure that we type our ref, which I believe is just a ref type like that. Get that imported properly. And this is an input element, so we can say HTML input element just like that. And there we go, we've typed everything up properly. And of course, this is optional, so I'll make it optional. There we go. So now we have access to this ref right here. I could say ref is equal to, and let's get our own ref here. So we can say const input ref is equal to use ref. And then we can put that into here. There we go. Make sure that this is an HTML input element, and we'll pass in null as the default value. And now I have access to that input ref. I can do whatever I want with it. For example, I can create a button that focuses this particular element. So let's come in here with a button that just says focus. And on click, what I want to do is I want to call my input ref.current.focus. There we go. So now if I give that a quick save and I make sure that I actually write my onClick function properly, there we go. Now when I click, it focuses me inside that very first input. This we are all used to with refs inside of React. But if we want to be able to get a ref that's more complicated, for example, I don't want a ref just pointing to my first input. I want a ref that allows me to access both of my inputs. This is where the use imperative handle hook comes in. This use imperative handle, if I spell it properly, this takes in a first property, which is the ref passed into your component. And the second property is essentially a function that is going to return to you a brand new ref. So here, let's say we return an object that says input 1 and input 2, just like that. And now we can reference both these. So I can say here, const input 1 ref, get a ref for an HTML input element, set that equal to null. I want to get a second one, just like that. There we go. So we can say input 1 ref, and for my second input, I can use input 2 ref. And now here, I can say we have our input refs being passed along, and this one is input 1 ref, just like that. So now essentially I've redefined what my ref is returning. Instead of returning just a single HTML input element, it's now returning to me an object with these properties. So I need to change my type up here. So we're going to have input 1, which is going to be an HTML input element, and it's going to be specifically a ref, just like that. And we can have input 2 ref, which is a ref to an HTML input element. There we go. And generally, when you're going to be writing code like this, it's better not to actually return the ref itself and just return the current value. So we're going to get rid of the ref typing here and instead just return the current value, just like that. There we go. And then I just need to make sure I wrap this entire thing in that ref type, since I'm saying that this is specifically a ref. Also, since current could be null, we just need to add the null type onto here, and that should clean up all of our different TypeScript errors. Actually, I just typed in this incorrectly. It should say input 2. There we go. And now you can see all of our errors have been cleaned up. The important thing though is now up here in my ref, if I make sure that I type this properly, I'm just going to copy this entire type so we can use the same exact type up here. I now have access to all those things. For example, I can get input1.focus. And now what this is going to do is focus button 1, and I can come down here with input 2 focus. So if I click the second button, it focuses the second input. If I click the first button, it focuses the first input. So this gives me a way to essentially expose additional information as a ref inside of React. Oftentimes when you do this, you're going to be exposing just a few functions or something like that. So instead of returning the full input, I may just return a function called focus1, just like that. And this focus1 function is essentially going to say focus on that element, just like that. There we go. And then up here, I could just say focus1. And here, of course, this should say focus1. And this would just be a function that returns void. And of course, I'll need to make sure I put that up here as well. There we go. And now essentially that gives me the same behavior. Clicking this focus is the first, clicking this focus is the second. So it's entirely up to you how you want to handle this. But this is a very common thing if you need to expose additional things as a ref instead of just a single input element, or maybe you need to expose some custom functions to work with your complicated component. Another thing that's really important is if you have dynamic values inside of here. For example, I have a state variable. It doesn't really matter what this state variable is. We'll just come in here and create a state variable. We'll default it to a string. I want to use that inside of here for some reason. Let's just say I return my state as is. This is actually going to cause you a bit of a problem because this is a dynamic property. So we need to make sure we pass it along with a dependency array. The dependency array just tells us essentially, do I need to re-render whatever this is? So I can put all my dependencies inside of here, and just like with useEffect or anything else that requires a dependency array, it'll only recall the code inside this function whenever the dependencies themselves change. So if you're not using any dynamic data, just essentially leave off your dependency array, make sure it's an empty array just like that, and everything is going to work just fine. Now, the reason I recommend not doing this too much is because this kind of breaks out of React's way of doing things. React is reactive. I mean, it's essentially in the name. It's a very declarative language. You declare what your UI is supposed to look like, and it reacts to your state changing. That is the exact opposite of an imperative workflow, which is what this use imperative handle is, which is where you actually specifically tell things like, hey, focus this element, do this particular thing, call this function. So instead of declaring what your UI is supposed to look like, you're essentially writing imperative code instead. This is why I only use this use imperative handle hook when I need to break out of the normal React way to handle something that cannot be done with standard state, props, use effects, and so on. And that is pretty much exceedingly rare in most of the code I work with. It's usually only any time that I need to combine together code from different libraries that aren't really React compatible, or if I'm writing some really complicated components that need to do some things outside of them that props and state, for example, cannot handle. Now, the very last hook I want to talk about, I'm only going to very briefly cover because it's probably one you should never be using, and that is a hook that is called use insertion effect. This use insertion effect works just like use effect, just like use layout effect. The only difference is when it runs and what it's specifically used for. This is used only for CSS in JS. Essentially, if you need to inject CSS code into your page, this is what you use. And since 99.9% of people do not write their own CSS and JS library, this is a hook that you probably never need to use. Now, it works just like a normal use effect. You can see here, we pass it our dependency array and we pass it our function, and we can even pass it along a cleanup function just like that to clean up anything that we need to do inside of it. It works just like a normal use effect. The only thing that you need to understand about this particular hook is that all of the code inside of here essentially runs before all your other hooks. It runs before your use layout effect, and it runs before your normal use effect. And the reason you want to put your CSS and JS related code in here, if you're like writing your own CSS injection library, is because it'll make sure it's more performant. If you use a normal use effect or use layout effect, it's going to cause lots of additional re-renders and paints on your page, which will slow down your browser as your CSS is updating, while use insertion effect essentially just makes sure it does all of the CSS updates that you need to do immediately at once, so that way you don't have a bunch of updates happening sequentially, which is causing your browser to slow down. But again, since you're probably not injecting CSS into your page from React, you don't really need to worry very much about this. 99% of the time, you can get away with just doing something like a style tag, or you can get around with class names, and that pretty much handles all of your needs. But again, if you are writing your own CSS injection library, or you're injecting CSS code for some particular reason, this is the hook that you're going to want to use for that particular use case. Otherwise, do not use this hook at all.